Hello, everybody. How are you? Happy weekend. I want to start talking about one of the two most important parts of the course, new ideas or whatever, and that's classes. We have basically gone over the same kind of material that you were supposed to get in 103, which is the major part of the major concepts of programming. Now, in the old days, that probably would have been enough. C++, the language, is derived from a language called C, which was developed at Bell Labs in New Jersey by Kernighan and Ritchie. I think that was the two. There may have been one other one. They did something unthinkable to businesses. They gave it away. Anybody who wanted it could have it free of charge. All they had to do was sign a statement that they weren't going to be discriminatory. So, not surprisingly, C became a very popular language. However, C was developed before object-oriented programming. And computer scientists love to have acronyms, so object-oriented programming is always called OOPS. And they put loops and hoops and all kinds of things using that OOPS. There's a annual conference called OOPSLA. So it's just one of those inside jokes that isn't really funny. Now, object-oriented programming has become the dominant style of programming. It's the way people program. So, C didn't have it. C also had an input-output structure that was a little bit difficult. I remember the first program I wrote in C, I made an error in an extremely simple program because I forgot how it does input. It needs an ampersand in a certain place, which doesn't seem to make sense until you really understand the language. So both of these were fixed in C++. And now we're going to go into OOPS. The struct concept we discussed in the last video abstracted the fields of a complex data item, for example, of a data item. I shouldn't use complex because it will be confused with complex numbers. For example, the first, last, and middle name of a person were part of a new data structure, data type, called person. The class takes the abstraction one step further. Now we're going to abstract both the data parts and the functions of a new data type. We create objects of this data type. So what we're saying is the class is the name of a new data type, and when we want one, we create an object of that data type. We could also say we instantiate an object of that data type. It's the same as saying int is a data type, but when we say int x, x is an object that is an integer. The object of OOPS is to try to program at a higher level. The concept is to try to hide lots of the details within the object. For example, we worked with complex numbers. Some of you are still turning in that project. Well, suppose instead I had defined a class called myComplex to represent complex numbers. Then if rad x and y are a type myComplex, I wanted to be able to write rad equal x plus y without worrying about how the real part is computed and how the integer part is computed. And you notice it's not a function, it's the plus sign. We'll be able to do that, but that's going to take maybe a week or two. We would like to be able to write C out rad, where rad is a complex number, and have it put out the input in the form a plus bi. Now we did that, but we use functions for it. Now we're going to see if we can use the same things we use for other types. This will be coming later too, but it's not trivial. So, let's say we're writing a program for bank accounts. We could have a data type bank ACK. And if ACK-C were a type of it, we might write ACK.deposit 500 or ACK.check 200. And have the class do the details of adding or subtracting from the balance, handling overdrafts, keeping records of the transactions. We wouldn't have to think about them. Well, there's a little fly in the ointment here. We wear two hats when we talk about classes. One hat is the hat of the programmer who uses the objects to write the programs. That's the programmer I was referring to up there, the one that just says ACK.deposit 500. That programmer doesn't want to know or doesn't need to know the details behind everything. They want to be able to think in higher terms. They want to be able to think of deposit the money, not take the money, check to see if there's enough money in the bank account. If there is, subtract it from the balance, keep a record of it. They don't want to do all those details. The object bank account, the object ACCX should do that. So that's the way that many people would like to work. And it could be that some people at our company work that way and let somebody else do the back details that I'm coming to next. The other hat we wear is the hat of the programmer who creates the code to implement the details behind the scene, whatever's going on. You remember the Wizard of Oz? The wizard was behind the scenes there. Well, the programmer wizard is behind the scenes making everything work. The class does this by recognizing two parts to a class. There's a public view of the class, which is how to create and use an object of the class, and a private view, which has the details. This division can also function as a security feature, because we'll just say the user can't touch anything. They can't get behind the screen. Only ways in are through my checkpoint, where I make sure he doesn't do anything I don't want him to do. So it's actually a protection method too. Now, a class has two parts for us right now, public and private. I put later 3 because there's a third part called a protected part. But we don't need to worry about that until we start talking about inheritance. The public part is everything the normal user is supposed to know. The second part, the private part, is the things that we don't want him to perhaps know. The things that implement whatever is going on. The division into two parts separates the object from its implementation. This is another good idea of OOPS programming. What it means is that we can define an object in a particular way, and then if we can implement it. And if we find a better way to implement it later, we just change the implementation. We don't change the way the user looks at it. For example, in C++, if I have a list in something, I might be doing it as an array, or I might be doing it as a vector. The user doesn't know. It doesn't need to know. The form of the class is somewhat complicated. There's a lot of syntax to get used to here. So first you have the name of the class. The word class in front of it, then the name of the class, then a brace. Then you have the word public : Now, public and private could go first. It doesn't matter what order they're in. And then under public, you have everything that you want to be known. And then under private, you have everything you want private. And then you have another brace and a semicolon. So notice you have two braces which hold together the class. And the public and private have colons after them. There doesn't have to be a private part. If you don't care, you have nothing to hide, you can just have a public part. Now I'm going to do an example. Actually, what I'm going to do is I'm going to go to the program I partially wrote to have this example. I haven't finished it. I left it so that we would do it. This is the bank account. I call it a check account here. It seemed more reasonable to call it a checking account. And here's the class. The class is checking account. In every class, I have to have what I call constructors. That is, how do I declare one of these? Now, actually, I think this one's automatic. I think the system will give it to you if you forget to put it in. It just writes checkac and that. That's called a generic constructor. It means that we create the object, but the object's empty. There's nothing in it. Now this one is a different constructor. It not only creates the object, but it also initiates it with the name of an owner, the account number, and the balance that's going to start it off. And it's a constructor also, but it has the ability to initiate also. Then we have what are often called accessors. They get us values. So get balance. We put in an account number, we get the balance back. Deposit an amount of money. That's a method. This is a method. And this is a method. Now, methods are nothing more than functions. But the word has been changed to method here. And if you notice, those are the only things a person can do. Now notice the person can't write out account number. A balance. He can't go get it. He has to use get balance if he wants it. I'm not letting him have it unless he goes through me. And he can't change it. That's the point. He changes it by depositing or cashing. He doesn't change it on a whim. Now that is the public face. Unfortunately, that private part is there because the compiler has to know about those things. Now we're going to get to the implementation. And this gets more messy, to my opinion. There's lots of ways to do this. I'm going to play a little bit of a game right here. One of the tricks I can do, I hate to do it the first time, so I'm going to do it down here. All right, I'll do it. That's a complete program. Brace, brace. It does absolutely nothing. But that's okay. That's all it's supposed to do. Now, I could have written a method in a minute to do that. I'll show you how I would do that for the check account. I want to write check account with string own int account num. I'm going to make that ACN and comma double val. Now I've actually left something out. I need to connect it to the check account. So here's the way I have to do that. I have to put the name of the class and then 2 colons. The 2 colons say, this is connected with check account. Also, the 2 colons mean that I can use anything in the private area. I don't have to worry about anything. So now I define it. I define it as follows. Well, I should put the word string in properly, shouldn't I? So here's how I'm going to define it. I want the owner to equal what I pass in, own. I want the account num to equal what I pass in, ac, n. And I want the balance to equal val. Now, for some reason, it doesn't. Oh, I changed this to account number, pardon me. Dash. No. And now that's finished. That's the function, it's finished. I'm going to put a semicolon because I'm going to go on to another function. So I've defined the first function. It happens to be a constructor. The next thing I have to define is this get function. Now again, I can do that very easily. The easiest way to do it is to just go up here and say, okay, do the following. Return the account. Oh, yeah, that's balance, pardon me. Return the balance. The usual brace and the bracket to end that. Now you notice that's a complete program and it returns a value. It returns balance. I could have written the program down here to do that, but for some of these that's easier to do it that way. So now let's look at void deposit. This again, I'm going to write as a function, method, and I have to say void, that's the type. Then again, I have to give you the name of the class, 2 colons, and then the name of the function, deposit, and again, its arguments, which are amount. And now I want to deposit it. But the deposit's easy. So I can just say balance equals balance plus amount. It may be I want to keep a record of that. So I might want another vector or something. But right now I'm just going to leave it that way, and that'll take care of that. Now the next one I want to define is the cache. So I need void check account cache and check num. So int check num and double, I think I called it amount. Yeah, AMT. And I have my function there. Well, now I want to pay the money out, but only if I have it. So I'm going to do something like this. If balance is greater than or equal to amount, well, let's go the other way. If the balance is less than the amount, then cout insufficient cash, insufficient funds, \n, there. And the user can decide what to do next. Else, I subtract from the balance the amount, and I had two vectors there. One was checks paid, and I don't know what this is. I know it's wrong, pardon me. I did this wrong. It just takes the word int. I'm sorry. So now, checks paid. I'll put checks paid dot pushback, and I'll put the check num in, CHKNUM. And I'll put amounts paid dot pushback the amount. I could write a note, but I don't see any reason to. We'll just leave it this way. So, again, let's see. I need another brace, I believe. No, I guess I didn't. So I'll just get rid of this one and put the semicolon in. Now, have I defined everything? I've defined the get balance, the deposit, the cash, and the two constructors. So I have everything. So now I can go down and show you how I would use it. So let's say I begin, and I'm going to define a check account mine, something like that. And I'm going to give it, let's see, the owner will be Joe, and the account number I'll assign to it is 100921, and the balance I'll put in is $500. Then what I'm going to do is I'm going to take mine, and I'm going to deposit now. When I deposit, what do I need? I need just the amount. So I'm going to deposit 200. And I'll make it 250. $200.50. Then I'm going to cash a check. The check num will be 104, and the amount I'll take out is $300. And now I'd like to know what my balance is. So I'll see out balance is get balance of mine. And perhaps I went too far here. Maybe there's no reason to put in the account number. Let's take it out. We don't need it. We need it there. We don't. Where's deposit? Now where's cash? There it is. I have cash here. Oh, it was get balance that I was going to read. Right. I don't have to change anything. That's it. So I'm just going to say mine.getBalance, blah, blah. Remember, it's a method, so it has to be as a function. And I'll do the indel. And then I will try mine.cash 105 $600, and I will again see out the balance is, and mine dot get balance indel, and I'll have return 0. Now look at the main line, it's very short. And I'm thinking in terms of the account. I'm not thinking in terms of checking things and more complicated things I might want to do later. Well, there's a chance I got everything right, but I doubt it. So let's see what happens. I knew something had to be wrong. All right, undeclared identifier. That's a pure spelling error. Let's see if that's it. I didn't fix it. I think I got it right. Let's see. Well, I got that right. Now let's see what I got wrong this time. Not define operator or conversion acceptable to the predefined operator. How can one line have so many errors in it? All right, let's see what happens. All right, we start out with a balance. Remember, I put 500 in it. And then I deposited 200, and I took out 300. I deposited 250. That took me to 750, and I subtracted 300. That took me to 450. Then I tried to get out more than I had in sufficient funds, and it didn't change the balance. So it worked fine. It worked the way it's supposed to. So that's my example for this particular case. I will put that in over here. I played around with a few things there. And we'll talk about this in a minute or two, but I want to get right here. What I'm going to do is I'm going to replace this with the actual thing I wrote. I think that's it, yes. Now, and I'll also put result of the program was, or let's say a run of the program is, and I'll get the output here for you. And there we are. Why don't I indent that a little? I think that's good enough. Now, a class has to have constructors. They have the same name of the class. They create an object. I don't need to put this here because I did it up above. Each of the methods starts with name of class, : Any method that begins with that setup can use the private items. We also, I'll put this as another point, we also can define simple implementations when we declare the method in the class definition. And you can see I did that twice back there. I did that for get, balance, and for the generic constructor. We've used accessors. We haven't used modifiers. Now, it's not necessary to use the word get, but I find it quite reasonable to. I think it makes it easier to know what we are doing. The form of the accessor I'm going to use looks like that. We didn't give the user any modifiers in this case. I actually wrote that, but that was a simpler case that didn't have the test. Oh no, that was what I had above. We can keep defining methods, many as we want. This is the beginning. It is a very small beginning because there's many, many, many things that happen with classes. But the most important parts are how you construct them, how you write them, and the concepts of methods, constructors, modifiers, accessors. We have to have them in many cases. For me, the thing that I don't like is how many of the things you have to write. I have to write gets, and I have to write sets for the modifiers, and I have to do lots of these double colons and things like that, and if I forget, the whole thing doesn't work. So the syntax isn't, to my mind, the most beautiful. I wish they had come up with something else. But that's it. That's the way it is. Okay, that's going to be for now. This is part 1. I believe I'm going to send out a homework for you to implement some of this very shortly, either today or tomorrow. So have a good rest of the weekend. Bye now.